Last lesson we looked at expansion and collecting of like terms, and this lesson we're going to do the opposite. We're going to have a look at some factorization. The first one we're going to look at is factorization using common factors. And our little definition here just says a common factor is a factor of an entire expression. So every term has to be divisible by this common factor. And ideally what we're looking for here is to be looking for the highest common factor, because when we take out the highest common factor, we'll have fully factorized it. So our first example wants us to identify the highest common factor and then use that common factor to factorize the expression. So what I'm going to do is I'm going to go over to the side here and write down the highest common factor before factorizing these expressions. So if we have a look at the first one, we're looking for a common factor between 3x and 15. Something that both of these terms are divisible by. And we can see pretty quickly that 3 is going to go into both of these terms. So our highest common factor in this case is 3. And what we can do with that is we can take our 3 out the front of our brackets and then inside our brackets we write whatever's left. And if you want to do a quick check to make sure that you've done it correctly, go through and expand this back out. So 3 times x is 3x, that's correct, and 3 times 5 is 15, so that's also correct. Our second one is 2y and y squared. We're looking at the highest common factor between these two terms, and we can see that y is going to go into both of them. So our highest common factor here is y. Both terms are divisible by that. We can grab the y, pop it out the front of our brackets, and then inside our brackets goes whatever's left. If we take out a y, the first term is left with 2, and our second term, we're left with a y. Again, a quick check, y times 2 is 2y, y times y is y squared. Third one, 4b and 8b cubed. Here we're going to look at the coefficient and the pronumeral term separately, pronumeral part separately, sorry. So if we look at the coefficient first, we've got 4 and 8, and we can see that a 4 is going to go into both of them. If we look at the pronumeral part, we can see that we've got a b and a b cubed, and b is going to go into both of them. So we can take out the highest common factor of 4b at the front of our brackets, and whatever's left goes inside. Quick check to make sure we've got it right. 4b times 1 is 4b. 4b times negative 2b squared is 8b cubed, so we've done that correctly. Having a look at our last one, we've got 2xy and 4x squared. Again, we can see that a 2, it will be a common factor, and if we look at the pronumeral part, we can see that x is also a factor. Okay, you've got an x and x squared there, y there, no y's there. Okay, so we can take out the highest common factor of 2x, and inside the bracket we'll be left with a y for the first term and 2x for the second term. Quick check, 2x times y is 2xy, 2x times negative 2x is negative 4x squared. Our second method is called grouping in pairs, and it's only used for expressions with 4 terms. What we're doing here is we're looking for a common factor in both pairs of terms, and we're going to take it out the front of the brackets. Okay, so the first example that we have here, it says to factorize this expression by grouping in pairs. So what we're going to do is I'm just going to underline our 2 different pairs. So we've got a pair there and a pair here, and I'm just going to write this expression out again. So we're doing x squared take 4x, that's our first pair, and our second pair 5x take 20. When we factorize this, what we're doing is we're going to look at that first pair, x squared take 4x. The common factor here is x, so we're going to take out an x out the front of the brackets, and what's left is x take 4 inside the brackets. If we look at our second pair, 5x take 20, our highest common factor here is 5, so we're going to take that out the front of the brackets, and what is left in the brackets is x take 4. If you're grouping in pairs, it's really important that these two binomials are the same, because what we're going to do now is take out a binomial factor. Okay, exactly like we were doing earlier when we were looking for our highest common factor. Our highest common factor between this red one and the green one is the binomial. Okay, so what we're going to do is take this out the front. It's x, take 4, and what's left inside the brackets from this term is x. What's left inside the bracket for this term is plus 5. Our next method is difference of two squared. We talked about this last lesson. You'll remember this identity when we've got two brackets that are exactly the same except one's a plus and one's a minus. We can expand it out in this way. It's called difference of two squares. We can take this identity and reverse it if we want to factorize. Remember that expanding and factorizing are just opposites of each other. So if we flip it the other way around and we have a squared take b squared, we can factorize that to be a plus b in one bracket, a take b in the other bracket. Okay, let's have a look at a couple of examples for difference of two squares. The first one is pretty straightforward, x squared take 4. And remember the difference of two squares can only be used when it's something squared minus something squared. So let's write it in that form first. Something squared take something squared. We just want to work out what our a and our b are. Our first term is x squared, and our second term, 4, is actually 2 squared. So we can see that our first term is x, and our b is going to be 2. We want to write it in the form a plus b, a minus b. So we're just going to pop in x plus 2, x minus 2. Let's have a look at another example. Sorry, we'll call this one A. Let's have a look at another one. B is going to be just a little bit trickier. 3 take y squared. I know what you're all thinking. You're thinking, how can this be something squared minus something squared when 3 is not a squared number? So what we need to do here is think about what squared gives us 3. Okay, if this is not a squared number, then this will always be the square root of whatever that is, in this case 3. The second one's easy, that's y squared. So again, we can identify our a and our b. Our first one is root 3, and our second one is y. Now that we've identified those, we can go ahead and pop them in our brackets. One will be plus, one will be minus. It's not a very good minus. Our first term is root 3, and our second term is y. Our last one looks kind of scary, but isn't. It's x plus y all squared, take away 25z squared. So same process. Again, what we're doing is we're looking to see what this is in terms of something squared minus something squared. Okay, the first one's super easy. It's already in that form for us. It's x plus y all squared. So nothing has to change there. Our second one is 25z squared. So what has been squared to give us that? 5z all squared. Okay, so again, we're going to go off to the side and think about our two terms. Our first one is x plus y, and our second one is 5z. So we're popping out our brackets. Because this first term is kind of big, I'm just going to put some kind of bigger brackets in. It's still going to be the same. One's going to be plus and one's going to be minus. And in this case, our first term is x plus y. Our second one is 5z. The last thing we're going to talk about today is factorizing quadratic polynomials. Now, quadratic polynomials are simply expressions in the form of ax squared plus bx plus c, where this a here is not 0. It's important that we have an x squared term. Okay, so that's what we're looking at. And last year we looked at using the cross method, and that's what we're going to use today as well. So here are our steps for the cross method. We're just going to follow these to do the next couple of examples. This example wants us to factorize this expression here, so I'm going to write it out. X squared plus 9x plus 20. And when I use the cross method, I always like to pop my brackets in first before I start any of this nonsense. We're just going to have a look at what our brackets will look like. Okay, I always look at the signs. Look at that last sign there. Now that operation is a plus. That tells me that both of these are going to be the same. Okay, they're going to be both plus or both minus. This one is also a plus. That tells me that they're both going to be plus. Okay, if this one had been a minus, they would have both been minus. Okay, now that I've got my brackets, let's get started. The first step says to list the factor pairs of the first and last term. So let's have a look at the first term, that's x squared. The factors that give me x squared are just x and x. Pop our arrows in. Remember, it's really important, the direction of the arrows, that's why it's called the cross method. And we're looking for some factor pairs of that last term, 20. Okay, so we know that 1 times 20 is 20, 2 times 10, and 4 times 5. They're all of the factor pairs that we have for 20. So all we want to go through and do is calculate the sum of each cross product pair. So the first one is x times 20, which is 20x, x times 1, which is just x. We want to then sum them up, and we get 21x. We're looking for 9x, so that 21x is wrong. Okay, I'm just going to cross that out, and we'll have a look at the second one. X times 10 is 10x, x times 2 is 2x, add them up and we get 12x. Okay, that is still not 9x, so it's still not what we're looking for. And hopefully this last one's going to work. X times 5 is 5x, and x times 4 is 4x. If we add them up, we get 9x, and that is exactly what we want. So I'm going to go through and circle these pairs. X and 4 go together, x and 5 go together. And then once I've done that, I can just write them into our brackets. Our next example says to factorize 5x squared, take 3x, take 2. So once again, I'm going to write that out and just put brackets in. That last sign says then different, and this one tells us the bigger one's going to be negative. But I'm just going to put in the different operations. One's a minus and one's a plus. That's what I'm looking for when I'm looking for my factor pairs. Okay, so the first step says to list the factor pairs of the first and last term. So that first one there is 5x squared. That means we're looking at 5x and x. The last one is negative 2. Now there's a few different ways of getting negative 2. You could do negative 2 and 1, or 1 and negative 2. It's important that you put it in the other way around as well, because that will give us different products. We also have negative 1 and positive 2, and the other way around, positive 2 and negative 1. We're going to do the same thing, multiply and add them up, and calculate the sum of each cross product pair. So 5x times 1 is 5x, x times negative 2 is negative 2x. If we add them up, we get 3x, which is not what we want. We don't want a positive 3x, we want a negative 3x. Okay, so that goes. 5x times negative 2 is negative 10x. X times 1 is x. Negative 10x plus x is negative 9x, and it's not what we want. 5x times 2, 10x. X times negative 1 is negative x, and that gives us 9x. Still not what we want. Always seems to be the last one. 5x times negative 1 is negative 5x. X times 2 is 2x. Add them up and we get negative 3x, which is what we want. So we go through, we want to select that combination, circle the pairs, and pop them into our brackets. 5x plus 2 is one pair, and x take 1 is our other pair.
To factorize on the CAS, again we find that under action transformation, but this time factor. Again, we just want to type in what we are trying to factorize, so 5x squared, take 3x, take 2. Again, be careful with your brackets, close that one off, and then hit execute.